The way that refraction is simulated in the Cycles rendering engine is missing out on one thing. In reality, glass is dispersive. This means that on the edges of what you can see through it, you get this chromatic fringing effect. Because what's happening is it disperses light based on its wavelength, or in the layman's words, it bends to varying degrees based on the color. Now there already is a tutorial by CG Cookie where he shows you how to get kind of a similar effect. What he's doing is using 3 glass shaders, one fully green, one fully red, and one fully blue. Then he adds them together using add shaders, technically creating what really amounts to a white shader that's really noisy and awful looking at first, that is, just because of how it randomly picks a shader to calculate. Next, he offers the IOR in opposite directions for the red and blue shader. IOR stands for index of refraction, and it means the degree to which light is bent, which again varies by the wavelength. One problem with his implementation though is that the fringing looks kind of harsh, and the reason why is that it's always sampling extreme hues and using fully offset IOR. In reality, it would look more smooth like a gradient, because it's spectral. I guess you could try and approximate using the roughness, but it might not be all that accurate. Now with due respect, there wasn't a very simple way to improve that at the time of his video. However, a new node has been added since then, and technically, it can be used for just this. The solution is to have the IOR and the color hue be a random value along their range when each ray goes off the material. So you would need a randomized value to influence them with. Now it does actually sample from different points within each pixel. So for example, if you use a really fine scale noise texture, the pattern might become apparent, and also has to waste time calculating noise textures, but it might produce a somewhat cool looking result. But now, let's set up a new method, starting with a glass sphere, as well as a checker texture I've added on this ground plane here, just so we have something to look at through the glass. Yes, I am fully aware this looks horrible, but we're testing. Previously, you would have had to do a bunch of complex math to get something even remotely random, because it doesn't really have the proper math operations. Actual PRNG, or pseudo-random number generation, may involve squaring numbers and isolating the middle digits. Now though, there is a random number generator with a slightly misleading name, the white noise texture. I mean, I feel like that could be categorized differently, like under input or something. Introduced with the release of 2.81, it generates a random number varying from 0 to 1 depending on the input. So if the input slightly differs, the output has a chance of being anything else. Anyways, it's all uniform because it's generating from the same value all across it. Changing this value makes it go rambunctious, but if you put a geometry input here and influence it with something like the position, it's now different everywhere, and it starts converging as different points inside the pixels are averaged out. This is now very similar to the random influence it uses when different rays are bounced off in random directions. So we can use that to influence the properties of the shader, like the IOR. So the accurate set of IOR values is typically above 1, where 1 is air and 1.45 is similar to glass, for example. Luckily, there are numerous ways to transform these, one of which being to use a map range node, which takes one range to another. Value is where you want to input the white noise, and the from values are just 0 to 1 by default, like the white noise. So just to exaggerate it, if you set the 2 min and 2 max to 1.4 and 1.5, this is basically very dispersive glass without the color. It looks sort of like it's slightly rough, but this isn't roughness. It's actually IOR blur, which is more directional. I feel like this actually is a very cool effect just on its own. But now, let's get to the color. If I put this same generator into the color, it might produce maybe a black and white fringing somewhat. But we want this to go around a color spectrum. One method is to put it through a color ramp. Now we could just add a bunch of points along, but it might be off balance. The way it's averaging by default is like a straight line on the color wheel, making it lose saturation at the midpoints. We just want to average the hue, so if I set this mode to HSV, it does exactly that. And as for saturation and brightness values, we want to keep those at a constant. As for this other option, near is just shortest length between it, which you don't want, and far is the opposite, leaving the other two self-explanatory. All you have to make sure is to get the full spectrum. So you want to adjust one so it's about a violet color, and the other hue just to the point where the glass snaps into balance in the viewport. Now because this is fully deterministic, if it generates 0.68274 for example, even if it's calculating that result twice, it would still actually use that number for both the IOR and the hue of the color, effectively mimicking the property of certain wavelengths refracting corresponding IORs. Just make sure it's the same white noise node to randomize both, or else you'll have to wait for this terrible chromatic noise to resolve for nothing. However, you can also use a hue saturation color node, which has more features you can easily take advantage of. If I put the white noise into the hue, it won't do anything until you change the color input to something fully saturated. And you can see we already have this very cool fringing effect. You can actually influence the hue of the fringing just by changing that color. Generally you'd think of it as red and cyan, or maybe green and purple, but I feel like not blue and yellow. You can see it's a bit dark for glass, because the other RGB channels of these fully saturated colors are 0. So mixing them together results in them averaging out to gray instead of white. To get around that, you can simply increase this value. You might think you want to set this to 3, just because of the earlier example of how to create dispersion by adding 3 shaders. But actually I found it makes it overly bright, which is not accurate. It should not be contributing more light than it can receive. So this spectrum also includes CMY colors. And as it turns out, magenta is 1 red and 1 blue, for example, so the spectrum value is actually averaged at half, meaning 2 is the correct brightness, and not 3. There's also a couple things you can do that make it look less accurate, but just for some extra license. For example, the saturation can be toned down, although it takes the color towards white, which again we're multiplying with 2. So the value should actually be 1 plus saturation, which you can fix once you have it in a no group, but I feel like if you watch that video, he explains no groups, and I feel like this process is self-explanatory, even though it's just a bit different. So first of all, he talks about the base IOR and the dispersion amount. Very similar here, you just create math nodes and put them into the 2 min and 2 max of the map range. Dispersion is also very sensitive if it increments by 0.1, so you can also multiply it with something like 0.1 or even less before feeding it into the offsets, because again, it should be used very subtly. It should not be in your face intense. Then if you create a mixed RGB node to multiply after the HSV node, the unconnected input color acts as a base color to multiply with. So now that we've tightened the graphics, one other thing that we can do is to add the creative license to loosen them again. So if I was to shift right drag over the connections of the white noise to reroute it, add a math node before the reroute, and set the operation to floor, you can see it looks terrible, because any of these random outputs, floor is just dropping them to 0. So if you multiply with 2 before it, it drops to 0 or 1. Then if you divide these numbers by the same value, that will squash them back to the old range of 1. So if it rounds to 1, that result becomes 0.5 around the color wheel. This effectively snaps it to an increment step, creating this stylized effect. And if this stepping is in between whole numbers, that could throw the hue off balance. So we also want to add in a floor node to fix that. Now currently, white noise times 1 is always floored to 0. So a stepping value of 2 creates 2 minus 1 step fringing, which is odd, so we can also add 1 to the stepping inside the group. If you change the stepping now, it at last represents the amount of steps between unique colors. Although, what if you don't want stepping again? Well, now you'd have to increase the stepping to an imperceptible amount of steps, forcing you to enter an infinitesimally large number, so we could also divide 1 by the value and use that instead. And that does mean the range for the value should be set to a min of 0, and a max of 1. So now to remove the effect, we can set this to 0. Except that makes it look like garbage, which would seem mystifying if you can't figure out the simple principle of mathematics that dividing by nothing results in infinity, which the computer will then try to approximate, resulting in just what you'd think, which is an error. One that results in all of the random values, rounding down to the largest number representable, that is. Never divide by nil. You could enter a small value, but then you're back to first world issues. So instead, insert an add node before everything else, and enter something very small, preferably around 10 zeros. Now adding that to 1 and dividing 1 by that creates less than 1, but with small enough numbers though, Blender seems to just not floor them when they go through a floor node. Certain small values get completely rounded, but things like 1e minus 12, it just seems to not care. So one last thing we can do is to invert the fringing, so we can invert the noise just before it goes into the value of the map range, or the hue, but then in between values would throw it off. We could round it though, which will clip it to 0 or 1. So that's it. Have I gone insane? Maybe. Have you? Also maybe. Did you just watch this video though? Absolutely. And now you have the knowledge to create this setup that you can add to any material. From now, all you'll need to do is to connect the color and IOR outputs to the corresponding sockets on the shader, provided that shader is either glass or a principled shader with the transmission value set to 1. And on the outside of the group, you have all of these parameters next to each other. And if you do all of this in a new project and select Save Startup, It's now there every time you create a new file. I might also share this setup so that you can save it to startup or append it into existing projects. So if you found this interesting, you can tell the algorithm. And as always, thanks for watching.